talk, and you are very welcome to the Red Lake Valley Village Hall and to the meeting of the Red Lake Valley Community Benefit Society. I'm a board member of the Community Benefit Society. We are at the moment primarily a small community woodland group, and every year when we have an AGM we bring along a keynote speaker, and these events are particularly well attended, and tonight is a very good turnout, so that's really good news. It's my privilege tonight to introduce you to tonight's speaker, who is Andrew Allott. Andrew was until 2 years ago head of biology at Shrewsbury School. He's still working as a biologist, he tells me, on exam work, international baccalaureate work, but he studied botany at Oxford, taught for some years in Kent, and then was it 26 years at Shrewsbury? 26 years at Shrewsbury School. Towards the end of his career, he started working on this book, which some of you may recognise. It's in the new Naturalist series, The Marches, which is a comprehensive study of the natural history of the marches. I borrowed this copy last week. I haven't finished it yet, but I've certainly read the bit on woodlands, and it is very interesting. So tonight's talk by Andrew is on woodland in the marches since the last glaciation and into the future. So without more ado, I'll just welcome Andrew and hand over to you.
Well, I feel it's my privilege to be invited to such an august community benefit society, and I think it's tremendous the work you're doing. And we had a walk up to the Quillet this afternoon, and it's a lovely wood, and I think it's fascinating, the project, and long may it go on, and all strength to your community elbows. I've put you up a challenge here. This is a map that's been produced by very accurate measuring of height above sea level. If you can't hear me, I've got a teacher's voice, so I'm generally loud enough, but if you can't hear me, then do shout out. If you disagree with anything during the lecture, I'm very happy to have hecklers, we can have the odd question at the end. I'm told to speak for 45 minutes, so it's just 8 o'clock now, so I've got to shut up at 8:45. And I'll try and stick to that. So here's your challenge. Can you find where we are on this map? I don't know if you've had a go yet, but all the names of places and the horrible roads have been eliminated. But I think we're up here, aren't we? Isn't that the Red Lake Valley there? I believe. I think so. So that's where you are. That's where we are now. Right, onwards. So there's my title, and I won't worry about that anymore. There's the book, which I wrote some years ago, and it's in the new Naturalist series published by HarperCollins, and it was my love letter to the marches and to the natural history of the marches, because I think it's such a wonderful area with fascinating natural history, and I wanted there to be a volume in this series to show to people more widely that we have a wonderful area, and we have wildlife and landscapes that are eminently worth conserving. Here's the marches in the lovely old Bartholomew's map, and George Peterkin had already written a volume in the series on the Wye Valley in this area down in the south, so I was left the northern and the central marches, this big flat, well not flat but low-lying plain, North Shropshire Cheshire plain, and then the wonderful hill country here where we're living. And so those were the two areas that were described in the book. The book's out of print, so I'm not here to try and flog you copies. You needn't worry about that. So I thought we'd have a look at woodland in the marches, and I'll try and make it as focused as possible on the Red Lake Valley. And just first of all think, well, how old is the woodland that we've got here? Your lovely wood up on the side of the hill here, how old could it be? There are some very ancient woods in the world, and it's reckoned this forest in northern Queensland is 110 million years old. I think you'll appreciate we don't have anything like that age. If we go to the Antarctic, we can take ice cores and bring them out, and they look like this. They've got little bubbles of trapped air in, and the deeper you go in the ice, the longer ago the bubbles of air were trapped, and you can get bubbles of air that are over 700,000 years old, and you can extract the CO2 from them and other isotopes of other gases, and from those you can plot this graph. I'm not having many graphs. I am a science teacher. I think this might be my only graph, so don't worry, it's not back to school. The red line tells you the carbon dioxide concentration in the atmosphere, and the black line tells you what the temperature was, the global temperatures. And you can see the two track each other very closely, and especially in the last 500,000 years, we've had a cycle where we've had rapid warming and then progressive cooling. Rapid warming, progressive cooling, rapid warming, and then the last cycle, rapid warming, progressive cooling, and that's the Devensian glaciation. Not steady, it's up and down, up and down, up and down, but getting colder and colder, and it got to its coldest 20,000 years ago. And then since then it's warmed up again, and of course we're now very warm, as we know today. Note, top left, that's 320 parts per million carbon dioxide. So none of these peaks got above, what, 300 parts per million carbon dioxide. That's the natural fluctuation. Now, what did that cause? That 100,000 years of conditions getting colder and colder and colder, and of course a glaciation, where ice sheets spread. And this is why we don't have any old woodland in the marches, because relatively recently there was a glaciation and ice spread down this valley and would have swept away any woodland that was here. Intensive research into this at the moment, various universities, they've got this Brit Ice modelling project, and I just thought I'd show you a, let's see, could it come up? I just thought I'd show you, is this going to come up? What do I do to get this started? This, if I can get this to work, this is a time-lapse sequence showing what's happened since about 40,000 years ago in terms of ice sheets. And if I can get it to work, it should have a bar at the bottom, which I can't see, which worries me slightly. Blue will be areas, blue up here, will be areas of stationary ice, ice caps that aren't moving. And then bright red would be ice that's really moving fast down valleys, glaciers that are moving down valleys. And the bit we would want to look at, I'm worried I won't get this to work, it's always worked before, would be this area here, because we'd expect ice to form in Snowdonia and to come down towards us here. Now, can I get it to work? Why don't I? Oh yes, it's working, yes. Right, so focus on us here. You can see we're 35,000 years ago, there's some ice forming. Do you see blue ice? An ice cap has formed, but then it disappears again. And that's what you'll see repeatedly. An ice cap forms over Snowdonia, and then it disappears again. But in Scotland, far more extensive ice. So we're now about 30,000 years ago, and again, ice caps form in Snowdonia, then disappear again. So no ice here yet. But now we're getting a more extensive ice cap forming there. It probably has spread down to us here, and there it's all the way through mid-Wales, but it's not moving much because it's blue there. Where there's red, the ice spreads out, then it all disappears again. So this is not a glaciation where the ice forms and stays permanently. We get ice caps forming, they disappear, ice caps forming, they disappear. But of course it's getting colder each time. And so the last of these glaciations, which we're coming up to, will be much the most extensive. And the ice will get a long way, and it'll come right down the valley here and get further. Can you see the blue ice spreading right over us there? And so this is all simulation, it's what scientists think happened. And then we finally end with this final flourish, ice coming right down through the marches. That's the greatest extent. Massive ice cover over Britain. See how far it goes, the bright red, the fast moving ice. And that's the maximum extent. So that's about 20,000 years ago, where much of central and northern Britain was covered by ice. And now it retreats, we get a few little extra flourishes, ice comes back into Snowdonia a few times, and it returns to Scotland, but here the ice has gone, and we're warmer, and the valley is not ice-filled anymore. So that's what's happened over the last, 100,000 years, ending with the maximum extent of the ice 20,000 years ago, and we end at 10,000, and then we're done. And you can see sea, by the way, the sea spreading back. See the coastline spreading back. So there we are. That's on the internet. If you find that interesting, you can get that off the internet. And I've watched this loads of times, and you see different things every single time. So that sets the scene. Ice came down this valley and swept everything away. And so what was the maximum extent of the ice? This black line shows us here. That's coming out. That's the Y Valley Glacier. And we're somewhere around here. But I've got a better map that shows us the extent of the ice. So this is, here we are. Let's see if I can find the Red Lake Valley. Are we here? I think we're here. Tell me if I'm wrong, or are we here? Somebody help me here. Which
that one. I think you're right.
That one?
Yeah.
Are we Red Lake there? Yes, I think that's the one. Yeah. So now the maximum extent of the ice is this black line here. So it goes just over Wenlock Edge, down to the west of these hills here, to the west of the area you were talking about with where the new chalets might be put up, or somewhere around there. So they were out of the ice. But here we were under ice, so we were ice covered. So the march is 20,000 years ago. Ice sheets covering much of the area. There would have been tundra on our higher hilltops, and also to the south and east of that black line that I just showed you. No trees and shrubs. 20,000 years ago, far too cold. But then the ice retreats. We get this relatively rapid warming. Now, we had a family holiday in Iceland some years ago, and we went to look at a glacier that's doing exactly this thing of retreating and melting. And so we went to Skaftafellsjökull, and this is ice, although it looks so filthy. That's the ice, that's the meltwater coming off. If you've not been to see a glacier like this, it is a fascinating thing. And that's the end of the glacier. And that's ice that's retreating fast. Every year it retreats by 100 metres or something. It's really going back fast. There's Alison all wrapped up warm, and that's the material left by the retreating glacier. I'm trying to give you an impression of what this valley would have been like when the glacier retreated back up the valley. And this is an area of relatively level, gravelly material called sandur. And this is also sandur. Just after the ice has retreated. But to the side here, we've got moraines. Now, I've checked up on this valley, and you don't seem to have much in the way of moraines. You seem to have mostly sandur. And so this is a map showing what you've got in this valley. And here's the Red Lake Valley, and the blue is those level areas of gravelly material, sandur. And so all the way up here, the base of the valley is filled with this gravelly material, which initially would have been bare. So 20,000 years ago, or 15,000 years ago, this bare gravelly material with a river running down the middle, probably running much faster than now because of meltwater and faster drainage. No vegetation to retain rainwater, so much bigger floods along the river. This is another map, geological survey map of your valley, and the blue, you can see we're here, which Chapel Lawn is here, and this blue is all the fairly level gravelly material left behind by the glacier. So that's what the valley would have been like, with almost no vegetation, and mammoths roaming up and down, no doubt. But then, as it gets warmer, vegetation can return, trees can return. So what's the evidence for this? What's the evidence for the return of trees? Here's the gravelly material. This is Iceland again. This is what your valley would have looked like. There's the River Red Lake with just bare gravel on either side. I know your valley isn't quite as wide as that, but similar. But can you see down the bottom here, just the start of maybe algae or lichens on the rocks, and then a bit later we would be starting to see mosses appearing. And as the weather gets warmer, plants can start to grow, and they return really quite quickly. As soon as the climate's adequate, then these plants will start to return quite quickly. So then we're starting to see little herbs returning. Incidentally, down the bottom of the valley here, this is what you've got, sandur level areas. You don't have so much in the way of moraines around here. You may know hummocky landscape near Shogden, for example, and that's where there are moraines. So more vegetation returning. I'm thinking this would have been, I don't know, maybe 15,000 years ago, something like that. And we're starting to see, oops, didn't mean to do that, starting to see little certainly herbs coming in, little shrubs coming in, there's a little willow there. These are kettle holes, those features there, which again, your valley is too narrow for you to have kettle holes. And more vegetation coming. And then really quite quickly, we can get the ground covered in vegetation. All the gravel's disappeared, and you can see we've got some heather flowering there. This is Racemitrium leguminosum, which is very, very common moss that grows in these conditions. But also, we've got willows coming. And quite soon after that, we're going to get birch. There's birch there as well. And that's about as far as we get in Iceland, because it's still cold there, and you don't get much beyond this stage. And you might expect conifers to come in next, but in Iceland they don't have any native conifers. They're too far away from seed sources, so conifers don't spread back in Iceland, not naturally anyway. But this valley would certainly have looked like that at one time. Now, how do we investigate what trees came back when? We do this by means of looking at the pollen record, and you can't do it in the Red Lake Valley because you don't have any deep deposits of peat, and so we have to go to somewhere where there is a lot of deep peat. For example, North Shropshire. This is on Fens, Wrexham or Bettersfield mosses, and you take a core of peat from the peat bog, but in places on those North Shropshire peat bogs there's 10 metres of peat, so you need a very long cord borer to push down into the peat, and you pull it out, and then you separate out each little bit of peat, you take out the pollen from it, and you can identify what tree species were there at the time the peat was formed by what the pollen was. They're looking rather pleased with themselves because they've got this massive peat borer. Now, this is a site near Colmere, which has been investigated just recently, and the peat depths are shown here, only less than a metre of peat, getting a bit deeper here, but this is the best core they got, 7.43 metres of peat in what just looks like a fairly normal boggy field actually when you visit it. And so the pollen from that has been identified, and this is the sort of graph that's produced, but that's too complicated. So this is a bit of an easier chart, and so this is the sort of data we can get to find out what trees returned when, so what would a woodland have looked at various dates. This on the left hand side, that's about 9,000, BP means before the present, so that's about 9,000 years ago, what pollen was there then. 6,060 you can see there, and then we're coming up to much nearer the modern times here. And each of these lines here is one particular tree species. So going from the top, birch, which came back very early on, Scots pine came back early, and I'm sure these would have come to your valley. Elm from early on, from more 9,000 or more years ago. Oaks, not many to start with, but then it built up here. Limes coming in only at about, what's that, about 6,000 years ago. Alders not much to start with, alders coming in bulk at that time. Ash coming in about there, but never very much. And here we've got hazel, lots, that came in early. And somewhere there should be willow, but here's willow, and willow from right way back. So that's how you find out what trees came back when, by looking at the pollen record. And we've got a lot of trees many, many thousands of years ago. So, when the woods came back, there would have been no humans in the Red Lake Valley, and so the woodland that would have developed would be entirely natural, so we call that wildwood. And the question I'm asking is, well, what type of wildwood would have developed in the Red Lake Valley? And we've got to answer two questions, and one is, well, what types of tree had returned to Britain after the glaciation? And then which of these would have thrived in the conditions which there were in the Red Lake Valley. And I'm going to try and make some guesses about this, but you may have views of your own on this. Now, how many trees came back to Britain? Well, it's reckoned 35, something like that, species of tree returned to the British Isles after the glaciation. Something like 35 species. But just for comparison, Poland is about the same land area as the British Isles. It's got a smaller north-south range, so less climatic variation, and yet it's got literally double the numbers of tree species. So we don't have many tree species in Britain, and the question is, I suppose we need to ask is why don't we have more native tree species in Britain? I'll try and answer that question because I think we do know the answer. We've got a relatively poor tree flora. Now, the answer starts to develop when you consider sea level changes and the extent of land. And this map shows you the extent of land 16,000 years ago. So this is where land ended 16,000 years ago. We've got a bit of a trench here, but apart from that, we're totally connected to continental Europe. 8,000 years ago, because of sea level rises, the coastline has retreated, but we're still very much connected to the continent. 7,000 years ago, we're still connected by a land bridge here. Now, if we're connected, then trees can spread north. As the weather gets warmer, trees can spread further north, and that's what they did. And that's how we get our 35 species of tree, by them spreading across this land bridge, either from Scandinavia, from the east, or from France and the Netherlands to the south. But then, about 6,500 years ago, the land bridge, I'm sure you know this, the land bridge was cut. And we became an island, and from then onwards it's much harder for trees to spread back. So if a tree hasn't got across by 6,500 BC, it's going to struggle to get across, and we would then wonder, well, did humans bring the trees across? And then, Dogger Bank finally, there was this island, Dogger Bank, that finally flooded 5,500 years before BC. So that's our answer. We're an island. It's hard for trees to spread back once the land bridge has been cut. Another problem for trees in Europe is the mountains tend to run east-west, and so they form a block to the movement of trees south during a glaciation and north again afterwards. Whereas in North America, the mountains run north-south. It's much easier for trees to spread north and south. Now, here's just one example. This is oak, and here it is 12,000 years before the present. It's down in the south of Europe. It's too cold further north. 10,000 years ago, it spread a bit. 6,000 years ago, it's got right the way up to Britain. So oak made it in time, and it's quite quickly right up to the north of Scotland. What about a couple of other examples? Norway spruce, that's its natural distribution, and Norway spruce never made it back to Britain. It will have been here before, but Norway spruce never got here in time. And indeed, even though it's called Norway spruce, it only reached Norway relatively recently. In fact, these colours tell you when it got to a particular area. And it only spread into Norway a few thousand years ago from the east. Beech, rather awkward maps here. Ignore the grey, it's the black blobs that matter. 3,000 to 4,000 years ago, no beech in Britain. There's no pollen record of beech in Britain 3,000 to 4,000 years ago. 2,000 to 3,000 years ago, we have beech in the south of England. So beech got across the sea somehow. Nobody knows how, because they're big seeds. But given that it got to Britain so recently, it won't very likely have got up this far north naturally. Humans brought beech up into these valleys. So your beech in Brennan Wood is not truly native, I think we would have to say. As I say, do stop me or argue if you don't agree with any of this, because I know some of you are experts in various fields, and you might want to challenge what I'm saying. I think earlier on I showed you Scots pine did get back to Britain, but we don't think of it as a native round here. Well, it was native for a long time, but it disappeared in the Iron Age. And there are two possible causes. There are stumps of native Scots pine in the mosses of North Shropshire, down in the peat. So it was there in Iron Age times. Two possibilities. One is the climate got much wetter and colder, and it was drowned out in peat bogs. Another is that humans cut it for firewood or whatever use, and whereas other trees will resprout from the base when you coppice them, Scots pine dies when you cut it at the base. So it could be an early extinction due to humans in this area. You chop the Scots pine down and it won't regrow. So that's a possibility with Scots pine. Now, which types of tree would have thrived in the Red Lake Valley? This is my full list of trees that I think will have got back to the Red Lake Valley and are therefore native here. And so it's just up to you to decide, well, which of these do you think thrive in the climate that you've got here? I don't know if there's any on this list you think wouldn't thrive in this valley because of the conditions. Quite a number of them I expect you'll recognise, you'll know where they grow. And we saw a fair few of these up in the wood. I just wonder about large-leaved lime, how that would do in this valley, or whether it's just
either limes.
neither currently, but maybe when it was a bit warmer some time ago. Yeah, yes. Any others we think wouldn't thrive here? I wonder about Quercus robur, whether that's truly native here. That's another possibility. Anyway, that's our cast of tree actors in the wild wood that could have formed here. And looking at other parts of the world, where, for example, in tropical rainforest, you could have literally hundreds of trees in an area 100 by 100 metres. This is very few. We've got very few tree species. Here they are, the ones that, or some of the ones on this list. That's goat willow, arrived early. Silver birch arrived very early. It's a pioneer and it can cope with cold conditions. You've got it up the top of Brunedin wood, I saw. Scots pine, as I say, did come but became extinct. And what we have now is reintroductions. Hazel came early. Sessile oak is what you have par excellence in your wood, and that's certainly native. Holly is undoubtedly native, one of our very few native evergreens. Wych elm, that's a big one, isn't it? We don't expect them to grow to that size, but there are some big ones. Small leaf limes. If you've not been surely with the wonderful wood of almost all small leaf limes in Worcestershire. That's a large-leaved lime which I've only recently been shown on Wenlock Edge. Absolutely vast large-leaved lime, pollarded. And that's Downton Gorge with both large and small-leaved lime. So these are the sort of trees we're expecting to have come into the woodlands in this valley, older. Black poplar, I struggle to find a wild black poplar, so this is the black poplar at Aston-on-Clun, which I'm sure you know. And you would certainly have been growing in this valley, even if we mainly find it in churchyards now. It certainly would have been native. Now, I've done a bit of homework, especially for you, and this is it. And I've done a section of this valley. This is drawn to scale. This is a section. There's, do you say Caer Caradog? How do you pronounce it? Caer Caradog. There's Caer Caradog on that side, dropping down this not so steep slope. Then we come into the valley bottom. Here we are, River Red Lake. Here we are at Chapel Lawn. Then up through your wood, much steeper, Brunedin Wood, and then up to a hill whose name I can't pronounce. Audrey Hill. So there we are. That's your valley. Now, one thing that's interesting. Look at sea level down there. Look how high we are. We're really perched up here in this valley, even if we're in the bottom of the valley. So we're high up in a Marches valley. Now, what types of woodland would have developed before humans came here? That's my question. This is my answer, which some of you might want to disagree with. I reckon because of the different conditions up either side of the hill and down in the valley, a variety of woodland types would have developed. And if we just start down in the bottom of the valley, down by the stream, I reckon there potentially would have been boggy conditions near the river, and perhaps we would have had older woodland there. Now, black poplar has been almost eliminated from Shropshire, but I'm convinced that in the past there would have been black poplar woodland. If we go to North America, we find extensive riverine black poplar woodland. Then we get onto fertile soil that's better drained, and there we expect to see what botanists these days call W8 woodland, which is mixed deciduous woodland with lots of different things in it. So W8 woodland. Then going further up the slope, we get into woodland where the soils are thinner, The woodland doesn't have such rich living, and we expect W10 woodland, mixed woodland, sessile oak, ash, holly, rowan, birch, hazel. I'm thinking, I don't know, 6,000 years ago, something like that. And then right up onto the hilltops, we expect W16 woodland, which is upland woodland, sessile oak again, but fewer species, and smaller trees. So that's my guess as to what wildwood would have developed here. And wouldn't it have been beautiful to have walked through those wild woods with a much greater diversity of trees and woodland types than we have today, and far more animal species as well. But we can't do that because of course, humans arrived and we changed almost everything. Here's